Hi everyone, welcome back to my channel. In my previous video, I have shown how to create the VPC manually as well as with Terraform. So this video will be the part 2 for the VPC. In this video, I will show how to create the instances in the public subnet and the private subnet and how to install the application in the private instances and how to connect to the private instances using the public instance, which is nothing but a bastion server or jump server. So without any further ado, let's get started. Yesterday I have created the Terraform script to create the VPC resource. So this is the script. Let's run this script and create the VPC. Terraform plan command. Terraform plan command will show what are the resources which will be created using the Terraform. So here you can see 13 to add. Okay. Let's give the command Terraform apply to create the resource with the option auto approve. Let's wait for the VPC to get created. VPC is created. Let's go to the console. VPC, your VPC is created. Now let's create the instances, one in public subnet, one in private subnet. Go to EC2, click on launch instance. Let me give as public. I will select Ubuntu image. I will go with free tier eligible. I will choose t2.micro as instance type. Either you can create the new key pair or you can select the existing one. So I will go with the existing one, which is the test. Now, as I have created the VPC, so I want the instances to be created inside that VPC. So click on edit in the network settings, select the VPC which you have created, click the subnet. I want my resources to be created in public subnet first. So public. So I need a public IP address for this instance. So I will enable this auto assign public IP. So create the security group. Let me create the security group over here. Let's give name as security group sg_tf. So this port is enabled. Okay. Done. That's it. I will click on launch instance. So the public instance has been created. This instance has public IP address as we have enabled the auto assign public IP while creating. Let's create one more instance but in the private subnet. Click on launch instance. I will give name as private. I will select image as Ubuntu. Same key pair which we have selected for the public one. Okay. Now again, I want the private instance to be created inside the VPC which we have created. Again, click on edit. Select the new VPC which you have created. For the subnet, select the private subnet to create instance inside the private subnet. Okay. Next, keep this as disabled as I don't want instance to have public IP. I will select existing security group, this one. Click on launch instance. Public instance is running, private instance is running. Public instance has public IP address. Coming to the private instance, there is no public IP. Now, to connect to the private instance, we need to have public IP, but there is no public IP. So how we can connect? We can connect using the public instance. So here comes a topic about bastion host or a jump server. So the resource which are used to connect to the private instances or the private resources is referred as bastion host. Select the instance, click on connect. I am inside the public instance. Now to connect to the private instance, we need the key, right? When we have created the private instance, we have selected the key. We need that key. So copy that key inside the public instance. We have selected the test key for this. I will copy the contents of the test key. So this is the content of the key. I will copy it. I will go to the instance, public instance. I will create one file over here. Let me reload the page. I will create one file, key. Okay. I will paste the content, save it. I will change the permission for the key. Okay. chmod 400 and the file name is key. So for the owner of the file, we have given only the read permission. Now let's use this key to connect to the private instance, and the command for connecting is ssh-i. Let's give the key name. What will be the username for the private instance? It will be Ubuntu. So we have selected Ubuntu image. Let's give Ubuntu user, Ubuntu @ let's give the private IP of the private instance. Hit enter. Yes. Now we are inside the private instance. Here you can see the IP 10.0.135.10. 10.0.135.10. Okay. Let's do sudo apt update. How does the private instance has connectivity to the internet? We are using the NAT gateway to provide the internet to the private instance to download the things from the internet. Let's install Nginx application over here. So the Nginx application has been installed. Okay. What if I delete the NAT gateway? Let me uninstall the Nginx application and I will show what happens when we do not use NAT gateway for the private instance. So Nginx application has been uninstalled. Let me delete the NAT gateway and I will show you what happened. Go to VPC, go to NAT gateways, click on NAT gateway, go to actions, click on delete NAT gateway. The NAT gateway is deleted. Let's go to the private instance. Let's try to install the Nginx application now. Sudo apt install nginx-y. It's still connecting because this private instance don't have internet connectivity. So that is the reason we are using the NAT gateway. So this is the reason we use the NAT gateway to connect to the internet. Okay. So NAT gateway helps the private instances or the private resources to connect to the internet. Let's go to this Terraform script. Let's give as Terraform, apply again without giving option auto approve. Okay. I will show you one thing. Terraform has detected that NAT gateway is deleted. So the Terraform is trying to create that NAT gateway. Let's give the value as yes. It's because that Terraform always makes sure that desired state always matches with the current state. Here current state is nothing but the resources which are running in the AWS, and the desired state is nothing but whatever the resources which we have mentioned inside the configuration file. So it's creating it. So Terraform has created the NAT gateway. Okay. Let's refresh this page. Let's connect to the private instance again. SSH-i, key name, username will be Ubuntu @ and the private instance private IP we need to provide over here. Hit enter. So we are inside the private instance now. Let's install the application again. Sudo apt install nginx-y. This time it will install the application as it has internet connectivity. See, it has installed it. Let's check the status of the Nginx. Sudo systemctl status Nginx. So the Nginx is in running state. So in this video, I have shown how to create the instances in the public subnet and the private subnet, how to install the application inside the private subnet, what happens when the private instance is not using the NAT gateway, and what happens when the private instance is using the NAT gateway. So without the NAT gateway, the private instance will not have connectivity to the internet. But with the help of NAT gateway, private instance can connect to the internet and download the things. Now accessing this application on the browser, I will not be showing in this video. I will cover that topic with the load balancer topic. Okay. So that's it. With the help of Terraform, I will show how to create the security group. I will show how to create the instances in the public subnet and the private subnet. So the VPC is destroyed and rest of the resources also. Now I will show you how to create the security groups, how to create the instances inside the public subnet and the private subnet with the help of Terraform. So without any further ado, let's get started. Let me open the main.terraform file. Resource. So security group resource type will be AWS_security_group. Let's give the local name as SG. While creating security group, we have provided the name. So let's provide the name. I will provide as security group_terraform. Let's provide description for this security group as I will give description for this security group created via Terraform. I will give group name as security group only. I will attach this security group to the VPC because in the network settings we have selected the VPC, we have created the security group. While using Terraform, when we are creating the security group, we need to mention the VPC ID. So VPC ID is equal to, again we need to use the implicit dependencies over here. So I will use interpolation technique, AWS VPC .main.id. We have created the security group. This will go and create the security group, but we need to open the ports for the SSH. Okay. For that, we need to create the resource block AWS_VPC_security group rules. Let me give inbound as a local name. IP protocol will be SSH. Port will be 22 for the SSH. We need to provide the destination IP address. So CIDR IPv4 is equal to 0.0.0.0/0 for anywhere I'm giving. Okay, I guess that's it. IP protocol, port, CIDR IPv4. Let me create the outbound rule. So security group has two things. One is inbound rule and the outbound rule. I have explained earlier what is inbound and outbound. Inbound is nothing but the request coming to the application. Outbound is nothing but the request going from the application or going out of application. The resource type will be AWS_VPC_security_group_ingress rules. Not the group_rule, it will be ingress_rules. For the egress here, egress means outbound, ingress means inbound. Local name will be outbound. I will give for anywhere. Okay. -1 means in Terraform, -1 means for every IP protocol like TCP, SSH, FTP, SMTP, for every protocol. Next, CIDR IPv4. The destination will be for everything. This is only for the demo. In real time, as I have said, we don't provide anywhere. We provide the resource IP address. Let's create instances. The resource type for the instance will be AWS underscore instance. Let me give the local name as public. So while creating instance, we have provided the name, tags. I will give name as Bastion host. As I have said, the resources which are used to connect to the private resources is referred as Bastion host or the jump server. Let's give the AMI ID. So AMI will be the image ID which we have selected. Let's give the image ID over here. While creating manually, we have selected Ubuntu as an image. Here we need to give that image ID. AMI is equals to the image ID. Just paste the image ID over here. And the instance type we have selected as t2.micro. Let's provide the security group over here. So security group will be VPC underscore security underscore group is equal to, in the list we need to provide the name of the security group, or we can use the implicit dependencies. AWS underscore security underscore group dot local name dot ID. For the inbound and outbound rules, we need to mention the security group ID over here. Okay. Group ID will be AWS underscore security underscore group dot security group dot ID. Same for the outbound, we need to provide. That's it. Now coming to the public instance, we have provided the name for the instance, we have provided the image ID, instance type, we have provided security groups. Need to provide the key name. So key name I will take as test, as we have created this key using the AWS console. As we are creating the instance inside the public subnet, let's provide the subnet ID over here. Public subnet ID. Okay. Let's use the implicit dependencies. For the public subnet, local name was public.id. Here I haven't used interpolation for the security group. Okay. You can even use the interpolation also, no problem. So I have provided the public subnet and we have enabled the auto assign public IP, right? So let's associate the public IP over here. Associate underscore public underscore IP underscore address is equal to true. Means this instance should have the public IP. Are we missing something? Tags, AMI, instance type, security group, I have attached it, I have given the key, I have provided subnet ID also, provided the public IP also. That's it. Now let's create the private instance in the private subnet. Resource, AWS instance, I will give local name as private. Again, tag. I will give name as private. I will provide AMI ID. Instance type will be t2.micro. VPC security group underscore IDs. It's not VPC underscore security underscore group. It's VPC underscore security underscore group underscore IDs. Okay. Let's provide the list. I will use interpolation. AWS underscore security group dot local name will be security group dot ID. Let's provide the key name, and the key name should be same as public instance. Okay, that's it. Let's provide the subnet ID. I want this instance to get created inside the private subnet. Let's use interpolation. Same again, we need to use the implicit dependencies. Dot local name for the private subnet was private.id. I will not use associate public IP address. If I use that thing over here, then this private instance will have the public IP, but I don't want this instance to have the public IP. So I am ignoring that option. Save the file. Give the command terraform apply or terraform plan. Let's see whether the configuration file is correct or not. There are two more commands in the terraform. One is terraform format. What this command will do is, if the syntax is wrong, okay, then it will correct the syntax. So everything is perfect in the main.terraform file. Another command is terraform validate. So this command will show whether there is error or not. Terraform validate. So it's showing error. Okay. It's not rules, it should be rule. Okay. And group underscore name, we need to remove it. That's the wrong option actually. Okay. Save the file. Now I can run the terraform validate command. It's throwing error again. Let's see what's the error. Security group ID is required, but no definition was found for the ingress rule. Okay. Argument named port is not expected here. Okay. Same goes for this outbound rule. Let's check main.terraform file. So here it should be security group ID, not group underscore ID. Security underscore group underscore ID. Same for the outbound also. Here it should not be a port, it should be to port and the from port. We need connection for the SSH to get inside the instance. So my request will go to this port. Okay, so to port. Now coming to the from port. I will give again as 22. Save the file. As you can see over here, we have given the syntax wrongly. Let's give the command terraform format command. Cat main.tf. See, terraform format command has corrected the syntax. Let's give terraform validate command. If there are still any errors, it will show it. So there are no errors. The configuration is valid. It is showing as success. Let's give terraform plan command. It's showing 18 to add. Next, terraform apply command with option auto approve. Let's wait till the resources are created. It's creating the NAT gateway. It will take some time. So the resources has been created. I've got the error regarding the AMI ID. So I have changed the AMI ID. VPC is created, instances are created. Let's check in the console. Go to instances. So two instances are in running state. Let's connect to one of the instance. So the Bastion host, which is the public instance, has a public IP. For this instance, there will be no public IP. Okay. So rest of the things are same like we have done manually, like login into the instance, copying the keys, then using that key to get inside the private instance and installing the application. That's it. Let's create a file, vi key. Let's copy the contents of that key. Save the file. Change the permissions, chmod 400 key, ssh-i. Provide the key name. Username will be Ubuntu for the Ubuntu image. Copy the private IP. Copy the private IP of the private instance. Paste it over here. Yes. Now we are inside the private instance. Sudo apt update and let's install Nginx application. Sudo apt install Nginx-y. So the Nginx application will be installed. Again I am repeating it. Private instance is connecting to the internet with the help of NAT gateway. Okay. Without NAT gateway, private instances cannot connect to the internet. The Nginx application is installed. Let's check the status of that application. Sudo systemctl status Nginx. It will be in running state. That's it for today. In the next video, I will show how to create the load balancer, how to attach this private instance as a target group to the load balancer, and how we will access the application which are running inside the private instance on the browser. Okay, that's it. Signing off.